Hey everyone, and welcome to 4.4, the second example, and this is about if you're trying to find the roots, not the exponents. So if we have the nth root of a complex number, the complex number u equals a plus bi is an nth root of the complex number z if u to the n equals z. So basically if we're taking this number and taking it to some power n, it's going to equal z. Alright, but what we're going to do is we're going to try to work backwards. What happens if we have z when we want to find u? Alright, so what we're going to do is we're going to use this. For the positive integer n, the complex number z equals r cosine theta plus I sine theta. Has exactly n distinct nth roots given by this formula right here. So that's kind of an important formula. It's also in your book, page 333. And so it's all this stuff. Z is going to equal all of that, where k is 0, 1, 2, 3, 4, all the way up to n minus 1. As soon as it gets to n, then it's just going to repeat itself around the unit circle. Kind of like if you have 4 pi, that's the same as 2 pi, which is the same as 0. So we don't need to keep on going forever. Alright, so what we're going to do is we are now going to do this example, and we're going to keep this because we're going to use this for this example. So it says find the cube roots of z equals negative 2 plus 2i. So I'm going to do real quick, I'm just going to grab it so I know where it is. Negative 2 to the left, up 2. It's going to be right here. So I know it's going to be in quadrant number 2. So first I'm going to do is I'm going to figure out what r is. Negative 2 squared is 4. 2 squared is 4. I'm going to take the square root, and that's going to be the square root of 8. For now I'm just going to leave it because I know it's going to happen later. You could rewrite that as 2 square root of 2, which should be fine, but I know things are going to happen down the line, so I'm just going to leave it as a square root of 8 for right now. The other thing I need to know is theta, and since it is over here and these are both the same number, it's like 45 degrees, but 45 degrees in the second quadrant is really 135 degrees. So I can rewrite this in trig form, which is how I want to do. So the first thing I'm going to do is just rewrite it in trig form and say z equals square root of 8 cosine 135 plus I sine 135. Okay, so now what we're going to do is we're going to use this formula. N is the number of roots. Since we're talking about cube roots, that really means 3. So that means I'm going to take the cube root of 8. And I'm going to take times cosine. And it's going to be the theta that I have, 135. And it's going to be plus 2 pi k, where k are all the numbers less than n. So if I'm talking about cube, I should say that k is going to equal 0, 1, and 2. Okay, so I'm going to start off with the 0 when k equals 0 for this first one. So it's going to be 135 plus 0 times 2 pi, which is going to be 0. It's going to be all over 3, which is my n value, right? It's the number of roots, so we can say that n equals 3, so I know I'm dividing by 3. And I'm going to also do plus I sine 135 over 3. Okay, now remember when I said don't take the square root down, the square root of 8? Well, what's the cube root of 8? It is 4. I'm sorry, it's not 4, it's 2. So it's going to be 2. And then we can take 135 and divide it by 3. And you get 135 divided by 3, and you should get 45 degrees. So it's really cosine 45 plus I sine 45. Okay, so it's going to be 2 times all that stuff. So if I want to rewrite that, cosine of 45 and sine of 45 is square root 2 over 2. So it would be 2 times square root 2 over 2 plus I square root 2 over 2. Almost running out of room. There we go. And then if I want to get my answer, multiply both of these by the square root of 2, or multiply by 2 and then divide by 2's would cancel out. You're left with square root of 2 plus I square root of 2. So that would be when k is 0. Now what happens when k is 1? So let's do the same thing. When we say k equals 1, we're still going to get the cube root of 8. Okay? And then it's going to be times cosine of 135 plus 2 pi times k. 2 pi times k is 1, so it's going to be plus, since we're in degrees right now, I'm going to keep it in degrees, plus 360 all over 3. And then it's going to be plus I sine of 135 plus 360 all over 3. Okay, now I'm just using degrees because I had degrees in the original. If you wanted to use radians, you could also do that. So 135 plus 360 is going to equal 495 divided by 3, and I should get 165 degrees. Now what should happen every time is that this number, after you divide by 3, should still be less than 360. Once it gets to be more than 360, we don't need to do any more. So we have 2 of cosine 165 plus I sine of 165. And then you can go through and you can find that one. And when it is 1, you should get, it's going to be about negative 1.366 plus 0.366I. Okay, so if you multiply, get the cosine of that, multiply by 2, you should end up with that number. The last time we have to do this is get k equal to 2, and so that is going to be the cube root of 8 times cosine of 135 plus 2 times 360 is going to be 720 divided by 3 plus I sine of 135 plus 720 all over 3. So 135 plus 720 is 855 divided by 3 is 285. So we should have 2 cosine of 285 plus I sine of 285. So when we get that, you should be able to get, distribute that in, and you should be able to get your answers. Alright, so if you wanted to type it in, I'll just do the first one just so you get the idea in case you kind of got lost in how I did the previous one. So I'm going to do cosine of, before I do that, let's make sure I'm in degrees. I am not. I am now in degrees. And I'm going to do cosine of 285. There's my number, multiply by 2, and I should get 0.518 plus I. We got sine of 285 times 2, and we should get negative 1.93. So it should be negative 1.93, or if you want to write it as 0.518 plus 1.93I. There we go. Okay, so that would be all of the solutions. We should get 3 answers. I've got one here. I've got one for k equals 1. I've got one for k equals 0. So there you go.